Welcome to my CCENT CCNA ICND1 study guide. This is dealing with Chapter 24, Network Address Translation, also known as NAT. In this chapter, we're looking at the perspective of an IPv4 address scalability. Basically, what does NAT do? We're going to be looking at NAT concepts, as well as NAT configuration and troubleshooting. So typically, use of a CIDR might be for us to mask an address. That's very common. So you have to understand the private address spaces. So class A is 10 through 10.255.255.255. Class B is 172.16 through 172.31.255.255. And class C is 192.168.0.0 through 192.168.255.255. So these are our private IP ranges. NAT allows us to map these private IP addresses to a public or to a pool of public addresses. And so what we have is this concept of private and public. This side of the network is all private. This is all public. So our source may be a private IP address, but it's actually going to take normally the outbound interface's IP address, and it will actually then transition. But you'll notice here, even though we have a source private IP address, it does allow it to go out all the way through to the internet. And that's because it's actually going to mask using this IP address here. So this IP address is probably that address. That way, to the outside, it looks like 200.1.1.1. However, in reality, it's really 10.1.1.1. So here's going to be the NAT change. On the inbound, on the return, the router will get a 200.1.1.1 on a port number, and that will tell the router, oh, that really means that is the mask for this internal or this private IP address, and then we'll map it accordingly. Static NAT showing the inside local and global addresses. Inside local, global address. All of these should be being masked by this 200. But notice here we have a pool. So 10.1.1.1 is going to map over to 200.1.1.1, where 10.1.1.2 will be mapping over to 200.1.1.2. We could do what's called static NAT, and that means it's a straight one-to-one. This guy will always map to that guy, and 10.1.1.2 will always map to 10.1.1.2, or sorry, to 200.1.1.2. These will all map one-to-one to each other. Have to love a slide with lots of information. Inside local, in a typical NAT design, the term inside refers to the address used for a host inside an enterprise. And inside local is the actual IP address assigned to the host in the private enterprise network. Inside global, in a typical NAT design, the term inside refers to the address used for the host. NAT uses an inside global address to represent the inside host as the packet is sent through the outside network, typically the internet. A NAT router will change the source IP address of a packet sent by the inside host from the inside local address to an inside global address as the packet goes from the inside to the outside network. Outside global is the term outside refers to the host outside of an enterprise, in other words, in the internet. An outside global address is the actual IP address assigned to the host on the outside network. So our inside local should be this guy right here. Our inside global. So we could map our TCPs like this. How do they know what specific address goes to which one? That's because each of these will do a randomized port, and that's how we keep them separate. If we're doing multiple connections, again, you notice the different port numbers. So this could actually be a router, and it has 3 requests for the same resource, because in reality, it's 3 separate hosts on the private LAN. So we also have this ability that it's called NAT Overload or PAT, and that is where we map everything to one public IP address, and that's where the random ports really come into play, because the NAT router will actually know our inside local and a randomized port. The NAT router recognizes those two, and they'll put out a specific public IP address with a random source port. That way they'll map. That way when the NAT router gets back the response for the IP and the specific port number, the NAT router will go, oh, that's really for this inside private IP address. But notice all of these are mapping to the same IP, but each of them have a different port number. That's part of that NAT overload or port address translation or PAT. Consumer routers with LAN and WAN ports normally do this automatically because this is like more of an all-in-one type device. So a consumer router has a DHCP server. Again, they already do PAT. That will be assigned a public IP address. All of our addresses on this side will be masked to that specific public IP address. So location of a DHCP server and NAT and PAT roles, it's normally always on the router. The NAT is always on the outbound interface. The DHCP server normally is on the inside portion of the router. So sample network for NAT, all of these will probably be masked to that one IP address. So how do we actually configure this? Well, 2 really important things. We have to do the IP NAT, and we have to place it on an interface. So to put it on an interface, it's IP NAT outside. The command to actually do the NATing should be IP NAT inside source static. If we're doing static, our inside local to our global address. So again, if we wanted to do a pool of addresses, we could do it right here. We'll do a access control list, and it will do the source list from our access list, and it will actually then assign those addresses to the Fred pool. And there is our Fred pool. So if we want to see if our NAT's functioning, we could do a show IP NAT translation or show IP NAT statistics, and we could actually see the translations and the statistics for NAT. Here's a little bit better because here's the NAT transition, inside global, inside local, and then the statistics. Examples of a reuse of a dynamic inside global. If we are doing it from a pool and we only have one public IP address, all of our private address are going to keep reusing that global address. Here is our, again, NAT overload and PAT. All of these will be mapped to that public IP address, and they just change the port number so that the NAT router knows which or what conversation goes to what address. So the last thing we have to talk about is how do we configure NAT overload? Normally we set it right here, IPNAT inside source list, set up the ACL, interface serial, and overload. That basically means says use the IP address from that interface. Overload means we're going to overload it. And then we go to that interface and we go IPNAT outside. And that's how we set our NAT overload. That's actually it for this chapter. Thank you.